Okay, here's number 3. Find the volume of the solid generated by revolving this region about the x-axis. This is a 3-part problem that I've made. I'm going to take it around the x-axis, but then we're going to go around different things. So far, it's been the x-axis every time. In part B, I'm going to have you go around the line y equals 7, which you can see right there in green, which is actually part of the border of the shape. And then finally, we're going to send it around this blue y equals 11 horizontal line and see what happens there. And notice the directions for all 3 parts say use your calculator around to 3 places. We don't want to get some crazy, crazy mental math going. That's not the expectation. Okay, before I began, I went ahead and made a little representative rectangle, and that's going to help me a lot. All right, we're going around the x-axis. As this spins around the x-axis, you can see that this representative rectangle that I've made is going to end up being like over here as well. And we're going to create what kind of looks like a washer. Have you ever done like home improvement projects, or if you've helped your parents? Maybe you've seen some of those, stainless steel washers that you put around screws so that, the wood doesn't get damaged. Or it looks like a donut, although this would be a really disappointing donut because the hole is enormous in the middle, but yeah, that's okay. So we're going to be using washer method this time. And the washer method requires 2 radii. A large uppercase R for the outer radius, and then a lowercase baby r for the inner radius, or the hole. Let's start with the outer radius. The outer radius would be the distance from here all the way down to the axis of revolution. Well, that's just simply going to be 7. It's 7 units. The inner radius, lowercase r, is basically the radius of the hole. So you would start here and come down to the axis of revolution. That's going to be the 1/2 x squared plus 5. I found year in and year out that this is the hardest part for students, is just being able to figure out, each radius. Once people can get this written on the page, the rest is pretty simple. Once in a while, people will forget, pi r squared. They'll forget the square of the radius, but that's unusual. Usually the culprit would be these 2 being wrong. All right, let's get the volume of this shape that we're creating here, this 3-dimensional object. It would be pi large radius squared minus pi small radius squared. I'm going to factor out the pi and then kick it all the way out. We're going to integrate from -2 to +2. Now, I have a calculator here, so I don't really care that I have a -2 as the lower limit. If I did not have a calculator, I would probably use symmetry, and I just double my answer, and I put a 0 down there. But I'm just going to leave it like this. All right, remember that the radii are getting squared. So you put in the 7, and that has to get squared, minus, then you put in the inner radius, which also needs to be squared. And of course, that's dx at the end, the differential. At this point, we're so happy that we have calculators. We're just going to type that in and get an answer. If you went through the long process, let's say that your calculator batteries died, or you had some time to kill, like several minutes, and you figured out the exact answer, which is numerically equivalent to both of the answers I have below. Okay, this time we're going to go around the line y equals 7. And so this is going to make some sort of an egg-type shape. Some sort of a football or maybe like a rugby ball. And we want to know, hey, what's the volume of this ball? Well, we're back to disk method because every single representative rectangle has direct physical contact with y equals 7. Every single one of those is hitting y equals 7. So there's no holes, no gaps, no need for a second radius. It's not washer method. In fact, what is the radius? How long is that green segment? Well, it's going to be top minus bottom. So it's going to be 7 minus this binomial. You do have to be careful because most people have the minus on the 1/2 x squared, but they forget that the 5 is also negative. So really the radius is going to be 2 minus 1/2 x squared, not 12 minus 1/2 x squared. It would be a 2. All right, to the volume. It's pi times radius squared. And again, like I just said, the radius is 2 minus 1/2 x squared. That will be squared. We're taking this from -2 to +2 again. As always, you could always go from 0 to 2, and you could put a 2 in front for symmetry. I'm just going to leave it like this because I'm allowed to use my calculator. Into the calculator it goes. You're going to end up with 128 pi over 15. But the direction said, hey, go ahead and round it to 3 places. So that is going to come out to 26.808 cubic units. All right, the last thing for today is part C. We're going to take the same region. We're going to take it around the line y equals 11. Clearly, this will be a washer method problem because you can see the gap being formed. I don't know if this helps or not, but here's the hole in the middle. It's tough trying to make a 3D object on a flat 2-dimensional board, but there's your washer. And there's a whole bunch of other washers that are spinning around, and together the washers will combine. We'll glue them together and it'll form a solid 3-dimensional object. Again, in my opinion, the toughest part of this is finding the outer and inner radii. The inner radius is a little bit easier. If you go from here, x comma 7, to right here where this star is, that's a distance of 4 spaces, 11 minus 7. It's always top minus bottom. That's going to be your whole or your inner radius. Now your outer radius would be from here to here. That's going to be your r. And again, top minus bottom. Here's the bottom. The top point, which by the way I never labeled, is x comma 11. So the outer radius will be 11 minus this binomial, which again is going to be 11, minus 1/2 x squared, minus 5, because the minus gets distributed into both of these. Well, 11 minus 5 is just 6, so let me clean that up. As always, I want to show my work. You don't want to just simply put things into the calculator and hope that you press the buttons the right way and maybe get no credit. So the volume is going to be pi. And once again, we're going from -2 to 2. Nothing has changed. It's going to be large radius squared minus small radius squared. Dx. Now there's flexibility as to how you can write this. If you don't want to write this in, you just want to say big R squared, little r squared, that's fine because you've already referenced what they are. If you don't want to write 4 squared, if you just simply want to write minus 16, that's fine as well. But don't bother foiling the first binomial out. Don't do any of this extra work. You want to use your calculator. The test will be way too long if you write everything out by hand. You'll never finish in time. This is going to end up being 256 pi over 5, which, rounded to 3 decimal places, is either 160.849 or 160.850 cubic units. Number 4 says set up but do not solve an equation to find the volume. And we're going to do the same region all 3 times, but we're going to go around different axes. You know, so far we've been going around the x-axis a lot, but now we're going to have a little bit of variety. So we'll start out with the x-axis in part A. There's the yellow region described in the directions, and I went ahead and made a representative rectangle. And now we're going to go around the x-axis. And as you can see, that red representative rectangle does not make direct physical contact with the x-axis. In fact, only one rectangle actually does even hit the x-axis. That'd be the one that comes straight down the y-axis. Most of them miss, so you're going to have holes and gaps. So this is a washer method problem, which means we need to find the outer and inner radii. Okay, this is going to superimpose on the other side, right about here or so. You can see the washer being formed. The inner radius, or the radius of the hole, if you will, is just this distance between those two green marks. That's going to just be x squared minus 0, which is x squared. The outer radius is the distance from here down to the axis, and that's going to be the x plus 2. So pretty straightforward. And since it says set up but do not solve, it doesn't really matter if I have a calculator or not. I just have to write out my formula, put a big box around it, and walk away. We're going to be integrating from x is negative 1 to x is 2, because we use those points of intersection to get our limits of integration. And then it's just big R squared minus small r squared. And that's it. That's the answer. It just says set up but do not solve. And again, if you want to write this as x to the 4th, that's fine. I mean, you could even FOIL that out. I wouldn't bother. I really wouldn't bother. I'd just leave it just like that. Save your time. Get on to the next question. Part B. Same region, but this time we're going around the line y equals negative 4, which is down there in green. Let me put one more point on that. This will be the point x comma negative 4. And obviously, we have no direct physical contact with that, so it's going to be another washer method problem. The outer radius is the distance from here to here. If you think about it, the x plus 2 would take you from here, the top, down to the x-axis. And then this other distance here is just 4 blocks. So really, it's going to be x plus 2 plus 4, which would be x plus 6. If that was too complex, I'm not trying to insult you, but seriously, if that was too complex, because a lot of people struggle with getting the two radii, just go top minus bottom. Top minus negative 4. That'd be plus 4. X plus 2 plus 4 is x plus 6. Okay, so that is the outer radius, capital R. Now let's go for the inner radius, lowercase r. The inner radius would be this distance from here down to the axis of revolution. Well, this microscopic little bit of distance right in here that I'm coloring in blue is just simply x squared. That's the distance above the x-axis. But then you have this extra plus 4 to add on that stretches the radius out. Or again, just go top minus bottom, and you have x squared minus negative 4. That'll give you the x plus 4. So those are your two radii. Now you just have to come up with an equation, circle it, and be done. There it is. The volume is equal to that integral. It's set up but not solved. And again, do not bother wasting your time foiling. You don't need to do that. That's what we want. Okay, last one on number 4, part C. This time, we're going to revolve around the line y equals 6, which is up there in blue. Let me put another point on that, x comma 6. Again, not surprisingly, with a bunch of white space in between the yellow region and the horizontal line y equals 6, it's going to be washer method once again. The outer radius is going to be from the axis of revolution down to the farthest point, so that's capital R. Again, just use your points. That's why I love making these representative rectangles, because I can just go top minus bottom. I can go 6 minus x squared, and I don't have to outthink myself. I'm done. In turn, this green part is the inner radius, lowercase r. Again, it's also going to be top minus bottom. Remember that this has a negative being distributed. So it's really going to be 6 minus x minus 2 as that makes its way in. So you're looking at 4 minus x. Well, that was the hard part. Now comes the easy part of simply just writing your answer. That's it for part C. That's it for number 4. All right, I wanted to keep the last couple days a little bit shorter just so you had some time in class to work with each other on this section, being that it's a little bit more difficult and it's easy to goof it up. So we'll come back for day 3. All right, good job, everybody.